Welcome to lesson 60, and in this lesson we're going to solve one-step inequalities. So you're going to look out for two things while I'm modeling for today. Look to see how I use algebra to solve the inequality. What is my system? What is my structure? What am I thinking about? And also how I represent that inequality on a number line. We'll jump into today's first problem. Solve the inequality and graph the solution set on a number line. So I have x divided by 1 and 2500ths is less than 12. So all they're asking me to do here is to figure out what the value of x could be that would make this inequality true. So what do we know? We know it's a number divided by 1 and 2500ths. We know that the value of that expression is going to be less than 12. Not a lot there. So look at my plan and then watch how I put it into action. I'm going to isolate that variable x, figure it out, but leave it by itself on one side. And to make 1x, that means I'm going to multiply both expressions by the denominator. So watch how I do that step. Then I want you to see how we simplify the expression. And finally, how I graph that solution set on a number line. What does that look like? What does it mean? And finally, you're going to see me test possible values for x. So hit pause so you can jot down this plan and then watch me put it into action. We're going to use our EE skills to simplify these expressions. So a number divided by 1 and 2500ths is less than 12. We haven't done these in a while, but remember, I want to isolate this x. So I'm going to use my inverse operation. So a number divided by 1 and 2500ths, so I'm going to do the opposite. I'm going to multiply it by 1 and 2500ths. And what that does is I'm going to end up with 1 and 2500ths x divided by 1 and 2500ths. And that's just going to leave me with x. So remember, whatever you do to one expression, you have to do to the other. So 12 times 1 and 2500ths gives us 15. So x has to be a number less than 15. So let's map this out. Normally, when we were doing equations, we would just substitute to see if it was true. And that will give us the number if it was an equation. It will tell us what it's equal to. But we're going to try this out. We're going to test it with a bunch of numbers. Let's try 3 numbers that are less than 15. So let's try 12. So 12 is less than 15. So 12 divided by 1 and 2500ths is less than 12. Let's see if that's true. 12 divided by 1 and 2500ths is equal to 9.6. So that is true. 9.6 is less than 12. Let's try a number greater than 15. I tried one that's less. Let's try 16. Okay, 16 divided by 1 and 2500ths. Ooh, here we go. Is equal to 12 and 8/10. So is 12 and 8/10 less than 12? Nope, that is not true. So we tried a number greater than 15 and we saw that it was not true. So we have to pick numbers that are less than 15. What happens if we pick a number that is exactly equal to 15? What do you think will happen? Will we get a true statement? 15 divided by 1 and 2500ths is 12. Is 12 less than 12? No. So it has to be a number less than 15. So think about this. I can pick any number and make that true. Like let's say I had 11. 11 divided by 1 and 2500ths. Yep, that number is less than 12. I can pick 2 divided by 1 and 2500ths. That number is less than 12. So it could be any number as long as it's less than 12. So watch how we actually graph this Math Marbles. We're going to make a line. We draw a number line. And in the middle of the number line, we put 15. And what we're going to do is we're going to highlight every single number that is less than 15. That is how we actually graph this. X is any number less than 15, but it cannot be equal to 15. So I'm going to put an open circle. And that is how we graph an inequality, is to show that we want all the numbers that are less than 15. And I can check that it's right because I want X to be every single number that is to the left side of 15. All right, hit pause so you can jot this one down into your notes. All right, we're going to do the same plan. We have 1/3 X is greater than 4.5. So we have a coefficient 1/3. We're going to divide both sides by 1/3. So X is greater than 4.5 divided by 1/3. Let's change this to an improper fraction. 4 times 2 is 8 plus 1 is 9. So 9/2 times 1/3, which is the same as 9/6. Let's change that back to an improper fraction. 9 divided by 6 is 1. And 3/6. Ooh, this one's taking me a while. And simplify this to 1.5. Alright, so X is any number that is greater than 1.5. We'll make this a true statement. Try this out. We can try a bigger, let's try a number greater than 1.5. Let's try 2. Is this statement true? 2 is greater than 1.5. Yes. 5 is greater than 1.5. Yes. What if you tried a number that was smaller than 1.5? I'll leave this in here. 2 is greater than 1.5. Let's try 1. Is 1 greater than 1.5? No. So we want every number as long as it's bigger than 1.5. So how do we write this down? Here's my number line. I'm going to graph it. I'm going to put 1.5 in the middle. And I want X to be all the numbers greater than 1.5. So are those going to be the numbers to the left or to the right? Well, I want the ones that are greater. So I want all of these numbers to the left. So I'm going to highlight it. I want every single number that is greater than 1.5. Can it be equal to 1.5? No. If it was equal, my symbol would look like this. It would have that equal sign at the bottom. Remember, it means to add. So it would be like that. And I don't want that number. So I'm going to leave an open circle. And I want every number as long as it's greater than 1.5. And how can you check? You would look at your number sentence and you have 1.5. And you want all the numbers, I'm going to use my symbol here, that are to the right of 1.5, the greater numbers. And that's again how we graph inequalities. Hit pause so you can jot this down. This is a little bit conceptual, but remember you can try different numbers on the number line to see whether or not it's true to help confirm your thinking. And that's it for today, Math Marbles. I will see you in the next lesson. Take care.